Hi guys and welcome back to my channel. For today I prepared for you, in my opinion, a very hard algebra problem. Let ABC be greater than 0. We have to show that a squared plus b squared over ac plus b squared plus c squared over ba plus c squared plus a squared over bc is greater than or equal to 4 times the quantity a squared plus b squared plus c squared all over ab plus bc plus ca plus the little 2 from here. How can we prove this inequality? Here I have a suggestion. Let's multiply on both sides with AB plus BC plus CA with this quantity. So let's see what we have. So here we'll have this quantity times this quantity from here, which is greater than or equal to 4 times this are cancelling, so we have all over 1 plus 2 times the quantity from here. By the way, this inequality is true if and only if this inequality is true. And now, as you guessed, we have to multiply this between them. So it will take just a little bit. Okay, so you can pause this video to see what I have multiplied here. This is how I multiplied. Now pay attention for b squared plus c squared, again c squared plus a squared and b squared plus a squared. We can add them. Now I copied this one, so we can subtract this sum 2a squared plus 2b squared plus 2c squared from here. And now if you see, here we have just 2a squared plus 2b squared plus 2c squared. Next I have observation. Let's take for example a squared plus b squared, sum of two squares. This sum can be written like a minus b all squared, but with plus 2ab. You can try this. This is true for all a, b real numbers greater than 0, as we have here. This is also true when we have c squared plus a squared. This is just c minus a all squared, but just minus 2ac. Sorry, plus. Here we'll do the same with b squared plus c squared, which is b minus c or c minus b, doesn't matter, plus 2bc. So we will substitute that in our inequality from all here. As you can see here, a squared plus b squared is a minus b all squared plus 2ab. Next, I did the same. And now here we will multiply. For example, here we can write b over c times a minus b all squared plus 2ab squared all over c. And in the other side we will do the same. But for example here, this is more simple, because it's equal to ac, as you can see, a over c times c minus a all squared plus 2ac times a over c. We can simplify this c with this c, so we have a over c times c minus a all squared plus 2a squared. Not like this. So let's get started to make these simplifications to all these sums. Okay, here I have an idea. Because we don't like this inequality, I'm thinking that these terms can make a binomial. How about the next binomial? Because here we have b over c times something, and here we have c over b times something. I'm thinking that b over c times c over b is equal to 1. So how can I do this? I have an idea. Let's take a look on this binomial. It's still ugly, I know, but let's decompose him. So we have this term squared, so b over c times a minus b all squared, and then plus from here c over b times b minus c squared, and then plus 2 times, in our case, square root of b over c times a minus b, and now times this one, the square root of c over b times b minus c. This is equal next to it. As you can see, b from here with b from here and c from here with c from here are cancelling out, so here we have only one. So is equal to this one plus 2 times a minus b times b minus c, which is equal next with 2 times ab minus ac minus b squared plus bc, which is equal next with 2ab minus 2ac minus 2b squared plus 2bc. And that's what we need to complete this binomial from all the terms from here. Because we have these two terms, b over c times a minus b squared and c over b times b minus c squared, we have to complete with this 2ab minus 2ac minus 2b squared plus 2bc. But here we will have another binomials. So I will cancel the terms that we used. Okay, now this binomial is equal to a over c times c minus a all squared that we already have, so cancel him, plus c over a times b minus c all squared from here, and then plus 2 times the square root of a over c times c minus a times the square root of c over a times b minus c. This is next with, because we already have these terms, plus 2 times, here from here we have 1, 2 times the quantity a minus c or c minus a in modulo times b minus c, which is equal next with 2 times bc minus c squared minus ab and then plus ac. That's what we need to complete the square from here. So we will write. And now we can form the last binomial from here. This is equal next to it. Sorry, I forgot the square roots. Here we have b over a times a minus b all squared, that here we will have, and then plus a over b times c minus a all squared. I think that's so here, and then plus 2 times the square root of b over a times a minus b times the square root of a over b times c minus a. We already have the terms, so then plus 2 times a minus b times c minus a. This is equal next with 2a c and then minus 2a squared minus 2bc and then plus 2ab. So we will write it. And now if we add them, we will need 2ab from here minus 2ab plus 2ab is just 2ab, 2bc plus 2bc is 4bc, but minus 2bc is just plus 2bc, and then plus 2ac from here as you can see, and then minus 2a squared minus 2b squared, and then minus 2c squared. So this is needed to be added from this inequality. Obvious, we are adding this because we want to form some binomials in the left side. And now to obtain this sum, here we see 2ab plus 2bc plus 2ac. This will be in this left side. Because we don't have this one, we will add first 2ab plus 2bc plus 2ac. And now, to write minus 2a squared minus 2b squared minus 2c squared, we see that we have here with the positive sign. So we have to subtract minus 4a squared minus 4b squared minus 4c squared to obtain here minus 2a squared minus 2b squared and then minus 2c squared. Let's see.